Major developments are underway for missions to the Moon and Mars, driven by NASA's Artemis program and SpaceX's Starship work. SpaceX recently achieved a significant milestone with its Starship rocket. The 10th test completed key objectives that advance both Moon and Mars plans. The Super Heavy booster completed a full-duration ascent burn. It achieved a successful hot staging separation. The Starship upper stage deployed a batch of dummy satellites. It later performed a successful engine relight in orbit. Both booster and upper stage completed controlled splashdowns. On the Moon front, NASA's Artemis program, with commercial partners including SpaceX, drives human return to the lunar surface. Astronauts launch aboard Orion on the Space Launch System rocket. In lunar orbit, crew transfer to a lunar-optimized Starship human landing system for descent. Artemis III aims to land at the Moon's south pole for scientific study. This will be the first human lunar landing since 1972. Astronauts will spend about a week on the surface. The full mission spans roughly 30 days. Artemis III is currently targeted no earlier than mid-2027. SpaceX has a separate, long-term plan to establish a self-sustaining city on Mars. In 2026, 5 uncrewed starships may launch to test landing on Mars. If successful, the first crewed missions could occur between 2028 and 2031. A return Mars mission is projected about 3 years, with roughly 9 months transit each way. The ultimate goal? Move millions of tons of cargo and eventually millions of people to build a permanent city. NASA and SpaceX share the long-term objective of expanding humanity beyond Earth. NASA focuses on science and preparing for Mars. SpaceX focuses on scalable transport and reusability. Astronaut training for Artemis is underway, with rigorous simulations and mission rehearsals. Yes, women are part of the crews. Artemis III is planned to land the first woman on the Moon. For example, Christina Koch is part of the Artemis II crew roster. But these missions face major technical and human challenges. Safely landing a large, human-rated starship on Mars is extremely difficult due to the thin atmosphere. In-orbit refueling, multiple tanker launches and precise transfers, remains unproven at scale. In-situ resource utilization must reliably make propellant and water from local resources. Radiation exposure from cosmic rays and solar particles is a major health challenge. Psychological strain from isolation and long communication delays will need mitigation. Martian regolith contains perchlorate, toxic for humans and agriculture. The greatest challenge is integrating many complex systems to work reliably on schedule. Extensive testing, incremental missions, and redundancy are essential to reduce risk. Human factors, crew selection, training, and resilience, are as important as hardware. Timelines are ambitious and may shift with new tests and data. Despite challenges, the shared vision remains, to make humanity a multiplanetary species. Subscribe for the latest updates as these missions advance from test flights to history-making exploration. Next stop, the Moon, then Mars. This is a SCO's media production. Be sure to like and subscribe to SCO's YouTube channel.